And now what is the state of spring? So let's assume that compressed. What will happen to compression in the spring? What will happen to the volume? Volume immerse will not change. What will happen to compression in the spring? Now I'm asking different things. It is fully submerged. When fully submerged, I think I need not to bother, no? Even if you want, you can bring the liquid. I'll change the level of liquid. So let it be. So I think we need not to bother like, sir, what happens to this one? It is fully submerged. What will happen to that one? So look at the sigma less than G. So which force will be greater? Band force will be greater. So definitely what do we expect the spring? Sorry, it is elongated. Spring, I need not to say anything. Sigma less than J. Spring will be elongated or compressed. Band force FB, the weight of the solid mg. Since band force will be greater than mg, so therefore the spring in fact will be elongated. So initial elongation, let it be kx1. Now the container will accelerate. Container at rest. So spring elongated or compressed, how do I come to know? Look at the density of solid and liquid. So now the buoyant force, new buoyant force will be this much. The weight mg, pseudo force, or mg plus ma, I'll write it. Then what about the new spring force? The new spring force, let it be kx2. I want what will happen to the spring, elongation increases or decreases. Are you able to understand? Let's see how we can write equations, nothing big. The body is fully submerged. Container at rest, container accelerates up. Body is fully submerged. Okay, let's write looking at this equation. Fb is equal to kx1 plus mg. Fully submerged rho Vg is equal to, this will be sigma Vg. So where all kx1 is there, we can, okay, we'll keep this equation in hand like this. Okay, now come for this equation. Fb dash equal to mg plus ma plus kx2. What is Fb dash? Rho V g plus a equal to this may sigma Vg plus sigma Va plus kx2. I'm just interested x1, x2 and x1 I wanted to compare, that's all. So this will be rho V rho Vg sigma Vg sigma Va plus kx2. Okay, fine. And now rho Vg, so what you can write it as kx1 so sigma Vg will get cancelled, so we'll end up with equation kx1 plus rho V, okay, this one, rho minus sigma Va equal to kx2. So what is x2 is equal to x1 plus rho minus sigma Va by k. Anybody says about the deflection in the spring? Rho will be, so what we can conclude here? Sigma less than rho or rho greater than sigma, then only the body, the condition. So rho is greater than sigma. So definitely x2 greater than x1. So what will happen to elongation will further increase. elongation of spring further increases. See, totally it is submerged. It is already volume immersed. That one. So I need not to change anything. So you do have two tricky situations. One partially immersed is different and totally immersed is different. Totally immersed, I think problem has become a little bit easy. The volume of the body is equal to volume immersed here. So you do have these questions in exam. I don't know students, you don't analyze here. You want to make a guess. How it is possible, tell me, without mathematics. Please, in almost all fluids, what all we have, no, you should not make a guess. There should be some equation should come. Through equations, we should conclude. Otherwise, we'll be in a very dangerous position. In SEORM also, there are 5-6 questions are there where he has asked theoretically. So students will think that, okay, just you have to remember. No, you should analyze mathematically. Please make a habit of analyzing it. I'll scroll down. Okay, we'll take the next. You see this?